Okay, good morning. Today's topic will be on multi-step equations. We did some of that yesterday. We'll review it today and just get more practice at it. And hopefully we'll have time to answer any questions that you have about multi-step equations. So we'll start with page 18 and page 19 out of your workbook. Page 18 doesn't have any problems on it. It just explains how to do multi-step equations. I'm going to go ahead and start my camera. So a multi-step equation is one that's going to take more than one step just to solve it. An example here. Oh, that's terrible. Here we go. This equation has multiplication in it, and it also has subtraction in it. To solve it, we're going to have to add undo the subtraction, and we'll have to divide to undo the multiplication. And those have to be done in separate steps. So, every one of these is going to can take 2 or maybe 3 steps to solve it. And just a review from yesterday, when you have an equation like this that has multiplication and addition in it, or multiplication and subtraction, you're going to want to do the inverse of subtraction or addition. So you're going to want to add or subtract first before you do the multiplication or division. So I think what I'll do, as you're working, I'll also work through these, and I'll work through them kind of slowly, and hopefully you'll keep ahead of me. But you could check back on some answers real quick if you need to check back. You can always check your answers to an algebra problem by taking your solution and plugging that number into the original equation and see if you made it true. Oh, then we get to fractions. Oh, no. Wait, is that a fraction?
Or divide.
Oh, what are we gonna do? What are we gonna do?
The answer is 2.
Don't we minus 6 on
Yeah.
each side?
Let's do
And then we do the inverse of division, which is
Yes.
multiplication.
Oh, yeah. Yay. And you win the prize. Okay, so this darn thing looks like a fraction, and it is. This is the symbol for division, so we can also think of it as a division problem. And like Kevin said, we just do the inverse of that, which is multiplication. So personally, I think multiplication is easier than division. And so if it looks like a division problem, it means we get to multiply to solve it. And in this case, I want to multiply by the denominator. And I have to do that on both sides. This cancels out here. This fraction ones are the easy ones. Let me make sure it's right. Oh yeah, that checks out just fine. Oh no, what do I do here?
5.
I don't like negatives.
Hmm.
Oh, you add 6 to each side.
Say again, Oksana?
You either add 6 to each side or you multiply 5 by 6.
This, all that we have left here is division. So we don't want to add, we just want to do the inverse of division, which is multiplication. What should we multiply by?
5.
Okay, let me show you what happens when we do that. And by the way, Kevin, you're not wrong. But, okay, we multiply by 5. This cancels. And I still have this negative sign here. So I need to do another step. I don't care what the opposite of x is. I want to know what x is. So to get rid of this negative, we have to multiply by a -1. So this negative times a negative just cancels out, and we end up at x equals -30. This, it always feels like an awkward step. There's a way that we could have, we could have made a different choice up here, and we wouldn't have to do this. So let's go back to this place right here. I'm going to recopy it. This negative sign here applies to the whole fraction. As it turns out, I could write this fraction instead of this way. I could write it as -x divided by 5. And that is the same, it's exactly the same thing. Or I could write it as x divided by -5. The reason why we can do it anyway like this is because if I have a positive number, no, let's do this. If I have a negative number divided by a positive,
It's always going to be a negative.
the answer is negative. If I have a positive divided by a negative, the answer is negative. Here's this thing, and they're showing that it's negative. So when I'm at this point, if I want to skip this awkward step here, I can say, well, I'm going to multiply top and bottom by -5. This -5 cancels out this negative and that 5. And we end up with x equals -30. Same answer.
How is that? I guess if you plug that in though.
Yes, let's plug it in and make sure that I'm getting the right answers, okay? So now that I'm saying, oh yeah, because that is odd, isn't it? Yeah. Okay, so I'm going to plug in -30 right here. And this negative sign doesn't disappear. So I would plug in -30 on the top, 5 on the bottom, and I still have the negative sign outside here. And I'm going to add 3.
Oh, I got
See if that equals 9. So -30 divided by 5 is -6. The opposite of -6 is +6. This whole thing comes out to be +6 plus 3, and that does indeed equal 9. Negatives. They're pesky. Okay. Now, this page is going to give us some practice on some things that we need practice on. Basic equations are just like the ones that you worked on the previous page. If you haven't finished those so far, let's leave those as homework. But let's look at some of these that are a little bit trickier. Separate variables. So here's one term with the variable n, a second term with the variable n, and they're both on the same side of the equation. So we can combine them. It's called combine like terms. And you want to do that first before you do anything else when you're solving an equation. Combine the like terms. So I have 4 n's, 3 more n's makes 7 n's altogether. And once I've done that, I have this one easy step. Since it's multiplication, I have to divide 7. N equals about 5. And we could check. 5 goes in there, and it also goes in there. 4 times 5 is 20. 3 times 5 is 15. 20 and 15 is indeed 35. I'm gonna let you work that one. I'm gonna cover up my work while I'm working it. Hey, it took me 3 steps to solve that. I don't think that you can solve it in fewer than 3 steps. I got 9. I got it right. 5 times 9 is 45. 5 minus 18 plus 9. Yes, works. And then we get to these. Oh no. Ugh. Looks like we have to add up these two fractions. Oh, it's subtract. We have to subtract those two fractions. Don't you hate it when they do something like that to you and it comes out to be an easy, easy answer? This is a great example to really make sense out of what's happening here. So this is division. We want to do the inverse of division, which is multiplication. We're going to multiply by 2. And we get that y equals 30. If we go back to this before we solved it, we're saying that half of a number, 15. Well, if half the number is 15, that number must be 30. It's easy to make sense out of it when we have a fraction like 1/2. It's much more difficult when we have some weird fraction like 13/16. Hard to picture what that means. Okay, this next row has terms with the variable on both sides. So up here, these terms are on the same side of the equation. You just add them up. But over here, when they're on opposite sides of the equation, you're going to have to treat this as something that you wish wasn't over here. To get rid of it, I'm going to have to subtract it from both sides. And then, of course, divide by 4. Oh, and then here's one of these. And Kevin decided he knows exactly what to do with this one first. Do you remember what you decided yesterday, Kevin? It was a great decision. So there's actually 2 different steps that we could do first, and either one is fine. But I like to get rid of this thing over here first. We're going to get rid of the term with the variable in it first. And secondly, we can get rid of this constant here. And Interesting. This particular problem, we didn't even ever have to multiply. Or I was expecting to have to. 4 times 23. I'm checking to make sure this is right. Oh yeah, I got way different answers. And that's because I did something wrong. Yeah, right. 4 times 20. Oh, here's. Oh yeah. Okay, so this is correct. It works. I'm going to subtract out the term with the variable on it.
With that, with 11,
This one? Do you have a question on this one, Oxy?
yeah, I actually got 5 on it somehow.
5 as an answer.
Can I tell you how I did it?
Yeah, let's see how you did it.
I subtracted the 7 from each
Okay.
side.
All right, let me do it that way. Because this, it's not wrong, Oksana. This is just as good a way of doing it.
Okay,
I still get 23 here.
23, 4n plus 3n. Then subtract 3. Oh. Okay, I actually subtracted 3 from the 23.
Oh, okay. So you can only take n's away from n's.
Okay, so it is 20. Sorry, I got 20 and then divided by 4, I got 5.
Yeah.
Okay.
And we could check when, so when you worked it,
Yeah.
you got an answer of 5, and you could check to see if that answer is correct by putting 5 in to the original equation. So let's see what happens when we do that. So
Yeah.
times 5
It's
plus,
23.
and we're going, does that equal 3 times 5 plus 4 times 5 is 20. 20 plus 7 is 27. On this side, we get 3 times 5 is 15. 15 plus 30 is 45.
Yeah.
So 27 does not equal 45.
No, it's 23. You're right.
Yeah, since those aren't equal, we know that this is not a correct solution. Right. So, let's see this one.
I got 17.
That's what I got too.
That's what I get too. Must be right if that's what we all got the same answer. Then we get down here to these with parentheses.
4.
Yeah, okay, 4. That's one truly, I can look at that one and I can figure it out. This is going to be harder for me just to figure out what it is.
It's 8.
And with this one, I only see, well, actually, that's okay. So for this one, probably the most straightforward way to solve it is to go ahead and do the distributive property here. So multiply 4 times the first thing plus 4 times the second thing.
Wait. Maybe not.
This doesn't look a whole lot simpler yet, except that we did get rid of the parentheses. It really is simpler. And then we have a problem just like these other ones we've worked so far. I'm going to start by subtracting 2 z's.
Oh. Oh, sorry. 20. Wait, no, maybe not. Hold on. It's 36. $16. Darn.
Yeah, 16.
Ah,
How many steps did that take us? Here's 1 step, 2 steps, 3 steps. It took us 4 steps to solve that.
I don't know why I got 8.
But each time it just got better and better. Now on this
It's
one,
making more sense with these bigger, lot more steps.
good. Now there's still, when you do a step and then once you get down to something like this, oh, we know what to do. And then you get down to this. Oh, yeah, there's only one thing I can do. It gets,
I had it right. The
Okay.
only thing I got wrong was 40 minus 8. I wrote 36 instead of 32.
yeah. And that is the kind of mistake that everybody makes, those little mistakes. And, you know, if you write down 36 and then everything else in the problem is correct, you think, oh, well, that student should at least get partial credit because she did most everything right. But the bottom line is, if the answer's wrong on the test, you either get it right or wrong. No partial credit on the math test. Just, I'll say this now, you can get partial credit on the language arts test. You can get partial credit for your essay that you are reading. But
I'm glad I actually got to write an essay that I felt all right with submitting.
yes. And even better when you got your passing score back, right?
I got 3 for that one.
Okay, on this one, well, let's see if 3 is right. If we put in 3 there. So 3 plus 2 is 5. So we would have 3 times 5. And is that equal to 3 plus 5 is 8. 2 times 8 comes out to be 16. Those are close, but they're not exactly equal. Somebody's going to have to solve this. And for this one, there's no reasonable choice to make except to go ahead and do the distributive property here and here.
So that would be 3y plus 6, yeah.
Then we have y's on both sides. Let's get rid of these 2.
So y is 4.
It could be 4, but
Yeah, I think 4 is going to work.
I was close.
You were close. 4 plus 2 is 6. 3 times 6 is 18. 4 plus 5 is 9. 2 times 9 is 18.
Oh, 4. So you got 4. Ugh,
You're so very close. Hi, Lynn. Just noticed that you popped in too.
Yeah, it's just a little loud over here. I'll just leave it on mute, but I'm here.
Okay, good. Writing down attendance. Here. All
So
right.
you already did the whole page already, Mary?
What's that? Say again?
You did the whole page already, this page? The whole multi-step equations review?
Yeah. That's what we just finished.
That's what I had to look forward to later, huh?
Yeah. We did page 18 and 19. And except I skipped over these as I was working them. But I'll send everybody answers for this if you need them. Yes? Everybody want answers?
Yes.
All right. Do that. Let's see what it is. Oh my goodness. Oh, it just looks peaceful sitting in the car. But I'm always glad to see that you're driving while you're on
So no driving ever when I'm on here.
your chauffeur.
Yeah,
Your chauffeur is driving you around.
we're gonna go to Silverton today. So
Isn't that fun? And I think it was you, Lynn, a couple weeks ago. You must have been holding your phone. And then you reached down for something. So from here, from this end, it looked like the car had flipped over. But you were still smiling. So I'm going, it probably wasn't the car flipping over. Probably. Yeah. And now we have Vicki in here too. Okay. While I'm thinking about, I'm just going to mention it right now. I saw an ad in the paper for a rather interesting job, and I'm just wondering.
Ooh, what was the job?
The job was, I'm wondering if anyone's interested in it. Working the front desk at a motel, and so Vicki, I need your opinion on this, and maybe you have the skinny on the inside of this. It's the Durango. I forget it. I can't remember the name of the motel now. It's the one that it used to be the Travel Lodge, and it's right next to Gazpacho's downtown. Anyway, they want someone to work 3 shifts a week. I think it's like, we'll say Sunday, Monday, and Tuesday from 6:30 a.m. to 2:30 p.m.
is that the Straighter?
No, it's not the Straighter. It's one of the other little motels downtown. But they want you to live there full time. And then
Really?
shifts. Are they saying they give you a place to live and you only have to work 3 shifts?
Live
Who
on.
knows?
It's
I'm
a
not
it's
sure.
a live on thing. Yeah, okay, if you stay on there, pretty much it's probably like a front desk on call. But then they could probably be looking for like a light maintenance.
You know, it just doesn't say that. It says work 3 shifts, but live there full time.
But would that be
Durango?
free or?
Anybody?
Durango Motel?
It's not the
That's the one by the.
It's not the Durango Motel. I'll have to look at it. It was, I saw the job ad on Craigslist.
Might be if it's the Durango. The only thing I'm thinking about is the one right by the high school because they have a live on site.
Yeah, and it's
No.
not that one. It's the one that's right next to Gazpacho's.
Oh, okay. That's
Yeah,
down
you know
on
which one I
the other
mean.
end.
Uh-huh.
Yeah, yeah.
Kind of a nice.
It's really nice though. I mean, the only thing is that maybe, if you're working 6 to 2, then if you're staying on site, that could just be like in case if you're going to be, if they need you, they'll ask you to answer after hours or something like that.
Yeah.
That could be on call, and that, I mean, that's an exchange for the room
Yeah.
and board kind of thing. So
Yeah. Okay.
I've been
Yeah, it's
looking
a lot-
for some
it's a
good
lot.
part-time jobs, and I've been looking on Craigslist a lot for around Durango and the other areas that are around here. There's some interesting things up there too.
I know. And there are actually job openings right now. Having a hard time filling positions. Okay, so what should we do? Let's look at, I'm going to get out my book and let's just look at some other problems. So here's this book again, the one we worked out of, remember which day. So here's the lesson on equations. And just glancing at these problems, these are so typical of the kinds of things that you would see on the GED test. And they kind of all look like word problems, right? I don't believe that they'll just give you a problem that looks like this.
There's some crazy word problems on the test, I'm sure.
Yeah, I saw very few just like that.
They're not going to give you stuff like this. It's going to be in a word problem. So let's look at this, just the kinds of problems. There's only so many different kinds of word problems that they can come up with. So if you've seen a lot of them, then they all seem the same with just a little different numbers. But they do use some particular language. Like this very first problem here, problem number 2, the first problem. The sum of 2 consecutive integers is 15. Which equation should we use to find the first number? Gosh, we better know what sum means and consecutive and integers. So we did have a lesson on integers, and an integer, the good news about integers, well, the bad news is that integers can include the negative numbers, but integers are only whole numbers and their opposites. There's no fractions, no decimals when we're talking about integers. So just thinking, oh, they just want me to come up with whole numbers, but they might be negative or positive numbers. Sum means the answer to an addition problem. Consecutive means in a row. So let's look at these equations here and see if any of them could make sense. Oh my gosh. Okay, we're looking for a sum. This one is subtractions, so, but I don't know. When I look at these answer choices, they don't look like anything that I would come up with the way that I'm thinking about this problem. So personally for me, at this point, I just want to try to solve it without the answers and then see if something like this looks like my way of thinking. So there's 2 numbers that are in a row, and consecutive integers, I could start listing all of them. 1, 2, 3, 4, 5, 6. And we're trying to think of 2 of these numbers that add up to 15. And I can write an equation for that. I can call the first number x, and that second number is just going to be 1 greater than x. And I'm going to add 1 greater than that. It's going to be x plus 1. Like if this number is 3, then the next number would be 4. 3 plus 1. And I want this stuff to add up to 15. So far, this doesn't look like anything that we have over there. So let's try to do some algebra to this. Here we have x plus 1. Oh, I know what x plus x is because I know how to combine like terms. X plus x is 2x plus 1.
Why is it not x squared?
Because x squared means x times x.
Oh, yeah. That's
Yeah. Okay, so then, oh, now, wait a minute. Now this looks exactly like that answer. Does it make sense? And we can actually check it and see if we like that answer. Let's do the algebra to this. So if I'm solving for x, I'm going to subtract 1. And we get that 2x is 14. It both sides by 2. And we get that x equals 7. Okay, so what does that mean? You have to go back to the problem. The problem says consecutive integers. What would you do to find the first number? The first number is 7. The next number after 7 is 8. Is it true that 7 plus 8 was 15? Yeah, it is. Oh. So, with this little two sentence problem here, they're checking to see if you know the definitions of these words. If you can, and they're checking to make sure that you can write an equation out of it. So, nice, a fairly complex question there. I have seen this, 2 consecutive integers. I've seen that phrase on almost every practice test that I've peeked at. So there's a good chance that you'll get a question like that on the GED test. Could be a little version of it. Instead of 2 consecutive integers, it might say 2 consecutive odd integers. So odd numbers are numbers that take that number and divide by 2. It doesn't divide either. So if I was going to list all of the odd integers that I can think of, first one is 1, and the next one is 3, 5, 7, 9, all the way up to as big as you can count. And this time when we talk about consecutive odd integers, they're the ones that are next to each other. So 5 comes right after 3, 7 comes after 5. So now when we have consecutive odd integers, there's going to be a gap in there. If the first integer is x, to get to the next consecutive odd integer, you're going to have to add 2 to x. Okay, let's try another word problem. like I've worked these. Didn't we work some of these the other day? Here we go. The cost of an adult ticket to the ballet is $4 less than 2 times the cost of a child's ticket. If an adult ticket is $20, how much is a child? Oh, I know how much a child's ticket is. It costs C. And I'm not trying to be a smart aleck when I do that. It really helps me, puts me in the right frame of mind if I can come up with a name for the answer here. So I'm using the variable C for child to be a child's ticket. And it gave us some hints here about the relationship between a child's ticket and the adult ticket. The adult is 4 less than 2 times child. So I can also say that adult is 4 less than 2 times the child. Two times the child's ticket less $4, and that should be the adult. But it also told us the adult is 20. So I can fill that number in right there. And now I have a 2-step equation that I can solve really easily for the price of this child's ticket. I want to add 4 to both sides. I'm trying to, that's where the background noise is. Okay, and then I need to divide both sides by 2, and I get that 12 equals the cost of the child's ticket. Then we can go back and make sure that this answer makes sense with the original description, which we wrote down like this. So if we double the cost of the child and then subtract 4 from it, it should come out to 20. When I double 12, 2 times 12 is 24, subtract 4 is 20. That works. Okay. And yay, there's the answer choice. Stephanie's age is 3 years greater than half of her sister's current age. If her sister is 24, what is Stephanie's age? I know Stephanie's age. Stephanie's age is A. Let's have it be A for Stephanie. Her sister is 24. But Stephanie is 3 years greater than half of her sister's current age. Let's think up some variable name for the sister. Let's let the sister be, I don't know. I'm going to say X. I don't want to say S. Because if I say S, I'm going to get mixed up between Stephanie and sister. So I'll let sister be X. And we know that the sister is 24 years old. Okay, but Stephanie is 3 years greater than half of her sister's current age. Here's the sister's current age. It's 24. And we want her to be 3 years greater than that. than half of her sister's age. Okay, so here's her sister's age. Let's take half of it. And then we're going to make it be 3 years greater.
15.
Looks like 15. Okay.
So you would take
Using-
greater as like a plus, and then what would be like, would times? They would just say times in a word problem.
Um,
Because I was thinking just looking at that like 3 years times.
yeah, no, greater would be plus. Times, I can't think of any other word that they would use besides times for multiplication. Unless they just said multiplied by. We'll see if we come across one that has that. Okay. Now we get to go to Music in the Mountain and listen to the cellos in the orchestra. The number of cellos is 2 more than 1/3 the number of violins. Okay, so there's 24 violins. And the cellos is equal to 2 more than 1/3 of the violins. There's violins, might as well put the number right into it. When you have a fraction and multiply, a lot of times the question will you have the word of. 1/3 of the number of violins. If it says fraction and of, it means multiply. 1/3 times 24 is 8. Plus 2 is this 10 cellos. There. Yeah, and that's, I have to think about the reality of this. In an orchestra, typically there are very many more violins than cellos. Violins aren't very noisy, so they have to have a lot of them. The bigger the stringed instrument, typically, I wonder if that's true. I was going to say they can make more noise. I don't know if that's true.
Cellos are pretty big.
Cellos are big. Yeah. Okay. These problems are all seeming kind of the same, aren't they? I like this one. Perimeter of the triangle is 16.5 feet. Which equation can be used to find the value of A? Well, let's think about what we would have to do to find this perimeter of 16.5. The perimeter is the distance all the way around. We're going to have to add up all of these sides and have it equal 16.5. So we can have A plus 2A plus 2A minus 1. And that has to equal 16.5. Okay, we've got 2, 4, 5 A's all together. If I combine these, they're all on the same side of the equal sign. Add 1 to both sides. Could divide both sides by 5. We get that A is some horrible decimal number.
3.5.
Oh, that's not that bad. Yay, A is 3.5. But that's not what the question is. Which equation can be used? Personally, I have a hard time looking at their equations and thinking, well, that's not how I would solve it, so I don't know what to do. Until after I've gone through and solved it, I'm going to look for some equation that looks like something that I've done here. Oh, wait. See all of that? There we go. So I can't see all of it. Your pictures are in the way. There we go. When I start looking through here, this very first answer here looks just like this step here. So that's the one. It's not that bad. This isn't that bad of a question, is it? Personally, I think it's easier than thinking about twice someone's age less.
It's understandable.
It is. And it like you can see the picture of it. Oh, we have time for a couple more. 4 times a number is 4 times less than 2 times the number. What is the number? I know what that number is. It's n. That helps me. Okay, and now I can write some kind of an equation here. 4 times n is 4 less than 2 times the number. Just translated it. I could be a translator. Okay, and this time it doesn't want the equation, it just wants an answer. Subtract 2 n's from both sides. 2 n's equals -4. 2 n equals -2. Let's check it and see if it's really true. If I take -2 and multiply it by 4, I get -8. Is that truly equal to -2 times 2 is -4. -4 minus 4 is -8. Yep, it's very true. Ooh, here's Julian. He collects rare political party convention pins. Number of Democratic pins is 14 less than 3 times the number of Republican Party pins. He has 98 pins in all. How many Republican pins does he have? Oh man, they really made this one cool. I know, he has R. That helps me. Now, Democratic pins is 14 less than 3 times Republican. Okay. It's going to be 14 less than, and see, here we go, Joe, 3 times. That's multiply. They had to use that word in there because we can't think of any other word to disguise it with. 14 less than 3 times Republican. And he has 98 pins in all. So here, to get 98, I'm going to have to add up the Republican pins plus the Democrat pins. If I go plus D here, I can't solve that because I have 2 different variables. But I don't have to say D here for Democrat because I've said that this is exactly equal to the number of the Democrat pins. And this is in terms of that same R variable that we have here. So I'm going to put, instead of D, I'm going to put this other way to express D. we go. I think we should combine these two terms here. Subtract 14. To get this R term by itself, we'd have to add 14. And then we can divide by 4. Memorized. Now I forgot what the question is. I can't even find the question. Oh, here we go. How many Republican Party pins does he have? I think it's 28. And again, we can check to see if that makes sense. If he has 28 Republican pins, Democrat is 14 less than 3 times. So 3 times 28 is 84. And it said 14 less than 84. Okay. So that comes out to 70 Democrat pens. And the original problem said when you add up the Republicans and the Democrats, you get 98. And that indeed works. And can you believe they made a stupid word problem out of that? Anyway, it's just an excuse for doing word problems. Oh, look, we can do this one. Let's do one more problem. And Kevin, this one's for you.
Really?
Didn't you say they gave you some, and you had to put some stuff in a big old long equation and you couldn't make it come out right?
It was actually really simple, but then it wasn't, because everything I tried just didn't work. I was trying to plug in variables, and it gave me numbers to plug in, but I tried plugging them in, I just didn't get it right.
Oh, it's got worse and worse, huh? Okay, this gives us a value for y. And then it wants us to solve for x. So I'm just going to put that 2.5 in every place where there's a y. So 10 times 2.5. And subtract 4 times 2.5 plus 2. And then I'm going to add 3x, and that's supposed to equal, oh, this will be challenging, 5 times 3 minus x. So I don't know how many times today I've said the first thing that you should do in an equation like this, the first thing that you should do in any equation, if there's just some plain old numbers you can add up or multiply or whatever, do that. So I'm going to start over here. 10 times 2.5. Oh, that comes out to be 25. 4 times, and then we're going to subtract 4 times 2.5 plus 2. This 2.5 plus 2 is 4.5. If I multiply 4.5 times 4, 18. Well, while I'm at it, I might as well go ahead and distribute this side. 3 times 5 is 15, and then I'm going to subtract 5 times x. So now we've gotten rid of all of that y stuff that was in the equation. We can still do this subtraction. 25 minus 18 is 7. Ooh, this is looking a lot better. Since I don't like negative numbers, I feel like adding 5x, that gets rid of that subtract 5x. It's here. It's looking better and better. Maybe subtract 7. Oh my gosh, did they really do this to us?
Made it 1.
1. It almost seems like a disappointment, doesn't it? But that makes it really easy to check the answer. Oh, except we have, oh no, it doesn't. Actually it does. You just put 1 in every place where there's an x. And you put the 2.5 back in every place where there's a y. The answer is going to come out to be x equals 1. Just know it. So with this problem, there's not a whole lot of complicated math to do. There's just so many numbers that you have to deal with all at once. This is one of those problems where it's real easy to make just a little tiny mistake. Hey. So this is what the GED test thinks of when it says you need to know equations. So you need to know how to distribute, how to combine like terms, and solving for the variable. But that's the work that you do after you have, in a lot of cases, after you've been able to write the equation that's going to help you solve some kind of a problem like that. There is practice in your KET lessons and this kind of questions, but I forget where they are. Let me look real quickly. I think I have it. So I can go, oh no, I have to go back to here. Don't you love it when I'm talking? All of this, when I'm chattering to myself, it all gets recorded on the video. Okay, so here's the schedule that I have been following, sort of. We're in week 4. This is day 2. We did multi-step equations, and the KET lesson is in the algebraic reasoning section, 3.2. And I can send that out to you. I'll send it out on an email. I always promise. Sometimes
Awesome. Thank you.
You're welcome. Got 2. And just glancing ahead at the schedule, next week, week 5, is all about geometry. And then week 6 is where we're going to do slope and graphing linear equations. I'll just show you what I have planned for the very last week. It's some of these more difficult topics. I've never even taught this lesson, evaluate polynomial expressions, recognize patterns. Those aren't lessons I typically teach. Kind of leaving that 7th week. It has the topics that you can pass the test without these, and they take a lot of work to really master them. So I put them in the 7th week because a lot of students will already have passed the test by then. And those of us who are left in the 7th week can decide if these lessons would benefit us or if we need to go back and review some other lessons to really master them. So, week 7 is still a big question mark in my mind. Okay, I'm gonna stop this.
Scary too.
All right, does anybody need anything from me today before I log out?
Nope. Thank
Nope.
you.
Hey, I'm gonna stop recording.